So, good evening, everyone. My name is Praveen Upadhyay. I'll be sharing my experience of how did I move one of the application that was earlier running on NoSQL, and then we moved it to Postgres. So, I'll directly jump into the use case. So, the use case that we have with our application is pretty simple. It has a very small size of data, but it has a very heavy reads and less writes. So, you can say it's like 90-10 ratio. And as and when the applications has started growing, we have started seeing the use case of querying multiple different columns that was earlier not meant. The other use case is that we need the read availability of this particular service to be 5 nines, and I'm emphasizing on read availability, not write availability, because this will play a key role in next slide. So why did the Cassandra plus cache failed? So we also tried the cache, right? So those who are familiar with Cassandra, they would agree that Cassandra supports a very strict query onto tables. So you have to design your table knowing what kind of queries you are going to make. If you switch to that query, you cannot make that on that table. You will have to either create a new table or go with a secondary index. That's not very much appreciated. So what you end up doing, because you have to do the query, you'll end up duplicating the data. You'll write the same data onto a different table, but now you'll modify your index patterns, which means that now it will have an inconsistency, right? Because it doesn't support the transactions, which means if you write to one table and if you fail to write to another table, you have an inconsistency. The other problem that we saw in our use case is the full partition read. And again, it's a very typical Cassandra thing. So if you are reading a full partition, that's not a very nice pattern for Cassandra because it is a resource-intensive operation. So what we did, we kind of added a cache at the front of DB, thinking that it is going to solve our problem. And to a great extent, it did, right? But scenarios like when I'm having heavy writes, in that case, the cache is frequently getting invalidated, which means that I'm not able to use my cache and I'm lying back onto the DB, which was earlier anyway not giving me the full potential, right? So I mean, after doing all of the patchwork, at the end we decided that let's not put more effort and let's move on to Postgres, which is actually going to solve our problem. And what it helps in doing so I am not going to create more tables now because I can create indexes on the same table and do the flexible queries. I can even utilize the joins, right? In order to meet the read scale, I can keep on adding the nodes, obviously to a limit, and I can serve more and more reads operations. We have also introduced proxy endpoints, which means that I'm redirecting my write operations onto a separate node and read operations onto separate node. And this is very important because if I'm loading my write node with the read as well, which in that case my write node is not available for writes, which it actually should have been done, right? Seamless failover, it typically means, because I just mentioned that the need for this particular service was 5 nines for the read availability, which means that I can survive a few seconds or a minute downtime with a write but not read. And Aurora Postgres works seamlessly when a writer node goes down. It promotes one of the reader node as a writer node. So your readers are always available, right? And to just make the queries faster, we have also introduced buffer cache. We are using the buffer cache of the Postgres to speed up the reads. The key outcome says all of it, right? You can see the kind of improvement that we saw after we moved on to Postgres. And it's written, so I'll not get into the details of it. But we went even one step further of it. We started using the Postgres Aurora serverless. And the serverless gave us a bit more ability to scale the things, right? Which means if I touch upon the last point, which is over-provisioned. So I can over-provision my nodes just to make sure that if there is any spike in the between during the time, I can go ahead and serve that without being worried about that I'm going to get a cost of that. Why? Because the serverless says that you'll be charged only for the resources you are actually using. So I can keep it extended. Then I am using a very specific feature of Aurora, which is custom endpoints. That I just talked about the reads and writes segregating, but I have also segregated the reads into two different endpoints. So there are async services which is calling to my service. I have segregated them into into one reader, and then there are critical reads that has to be performed. I have segregated that into a different read, which means now I am able to even balance out my read load with that. So I just want to say with that, that was my last slide. I just want to say that, please challenge yourself. Do not try to patch with the tech stack. Choose the right tech stack. Thank you so much.